Here we are at example 10 from our 8.4 set of notes. We're looking at multi-step simplifying. When we look at example 10, we notice that we have several different things being done with an operation, whether it's multiplying or divided by. And you can go ahead and factor right away. In fact, let's go ahead and do that first. If we go ahead and just look at this top left item, that breaks down into x times x minus 3. On the bottom, we can go ahead and break down this one. It comes out to be x minus 3 times x minus 2. We have a multiplying symbol between the first item and the second item. Up here we have the difference of two perfect squares, so that's x plus 2 times x minus 2 divided by. It looks like we can pull a 3x on the bottom. And so we would be left then with 2x plus 1. And then we have our division symbol. Pulling a 2 out of this top right piece. We would then end up with x plus 2. And on the bottom it looks like we can pull out a 3. We would have 3 times x plus 4. So all we've done so far is just gone ahead and factored out all of these different items. Now, it's important to know, well, which operation is being done first? Do you start looking at these two? Do you start looking at these two? Pretty much, if you recall back to PEMDAS, what we do is we read these things from left to right, terms with various operations from left to right. So what we're going to go ahead and do is go ahead and actually change this last piece into a multiplication and go ahead and flip this guy. So the reason why we're talking about flippings is because you might have different items being divided by, and it can be really hard to keep track of where the flips are happening. This first one, we notice that there's no flips at all because it's literally just a multiplication. The only time you flip is when you are dividing by another rational expression. So we have x times x minus 3 divided by x minus 3 times x minus 2 times x plus 2 times x minus 2 divided by 3x times 2x plus 1. And again, we're going to go ahead and change this to a multiplication and flip this rational expression. So we have the 3 times the x plus 4 on top now. And on the bottom we have our 2 times x plus 2. Now, fortunately, multiplication is commutative, so we could look at these first two together, or we could look at these second two together. Order really doesn't matter, and as a result, we could, even if we really, really wanted, we could look at the first one and the last one all at one point and kind of bypass the middle guy. So that is the commutative property for multiplication, and pretty much right now what that translates to is we can go ahead and do our simplifying, or we can cross things off. So looking at what we can go ahead and cross off, it looks like we have an x up here, a 3x on the bottom. Looks like that x can drop out, just the x. We have an x minus 3 on top. We have 1 on the bottom. Those can cancel out. Moving on to this x plus 2. I see 1 over here on the bottom. X minus 2. Yep, there's 1 on the bottom. This 3. There's a 3 on the bottom as well. And x plus 4. It doesn't look like there's any more x plus 4s, so we are left then with that x plus 4 divided by 2 times 2x plus 1. So this would be our final simplified version. Again, though, that is example 10 from our 8.4 set of notes.